Okay, so we are going to pick up where we left off last time. Last time we talked and finished up the first goal of I can translate verbal expressions into algebraic expressions, equations, and vice versa. So expressions and equations, we were able to change it from verbal to the actual equation or expression. And we started on working on solving equations using the properties of equality. So we are going to just quickly scroll down to the section that we were working on. We ended with talking about the distributive property. Remember the distributive property is we have something on the outside that's being multiplied to something being either added or subtracted on the inside. And it's equivalent to saying that the first times whatever's inside plus or minus the first whatever's outside times the second thing that's inside. So whenever you're actually solving an equation, it's good to know kind of what steps we need to take. In order to solve an equation, we have a certain guideline that we do. One way of thinking about it is we could think about PEMDAS, remember order of operations. Whenever you're dealing with an expression, simplifying expression, we use PEMDAS. Whenever we solve an equation, we use reverse PEMDAS. However, that sometimes may not be 100% clear. So I'm going to give you a 5-step thing to be able to know what we are going to do in order to solve an equation. Step number 1 is we are going to simplify each side. So if there are parentheses, let's go ahead and distribute those. If we have fractions, let's get rid of those fractions. If we have decimals, we can get rid of those decimals during this step. Simplify both sides so that it's a nice, easy look. Remember, this is for linear equations, not any others. So simplify. The other step, step 2, I'm actually going to do this in a different color. Step 2, we are going to move the variables to one side. Step 3, move the constants to the other side. Basically, we're going to move all the variables either to the left or to the right, whichever one makes the most sense, and then move the constant to the opposite side. Okay, so that we have them across from each other of the equals to sign. Part 4 is we are going to isolate the variable. Because at this point, we would only have one variable instead of there being multiple. Then the last step, step 5, we are going to check our solution. So that's our 5-step process. Really just 4. The 5th one is kind of just an extra step just to make sure that we did everything else correctly. Okay, so it's more of a 4-step instead of 5-step. And you could argue that step 2 and 3 could be done at the same time as well. So let's actually solve a few equations. Let's take a few linear equations and see what we can do with them. So part A of this is we have -4 times the quantity of the difference of 7x and 12. And this is the same as the difference of 100 and 2 times that same number, the x. Okay, so let's go ahead and simplify each side. Make sure that it's as simple as we can get it. We already don't have any fractions, so that's fine. But we do have parentheses, so let's get rid of the parentheses by using our distributive property. Okay, so -4 times positive 7x is a negative 28x. -4 times -12 is actually positive. Negative times negative is positive. 4 times 12 gives us a 48. And that's equal to 100 minus by 2x. Okay. This seems pretty simple on both sides. We have no fractions, no decimals, no parentheses. It's just our numbers and our numbers with variables, our constants, and then our other terms. Okay, step 1 is complete. Move on to step 2. Let's move all the variables to one side. It does not matter which side you move the variables onto. For simplicity's sake, just so I make sure I end up with a positive variable, I'm going to move the 28. Remember our property of equality, we have a negative 28x. Opposite of a negative 28x is going to be a positive. We will always want to do the opposite. So this is negative. Opposite of negative gives us positive. So we need to add 28x to both sides. And what this does is it gets rid of the 28x on the left-hand side. We're moving all the variables to one side. So this gives us 48 equals to 100 equals to 100 plus 26x. We have all the variables on one side. That moves us to step 3. Let's move all the constants to the other side. Well, the only constant we have on the right-hand side with the variable is 100. That's positive. Opposite of a positive is a negative. So we need to minus by 100. Use our negative of that. So this would be 26x on this side. And 100 minus by 48 is going to give us 52. In fact, it's a negative 52, right? 100 is a bigger number in general, but it's negative, so it makes it farther negative, so that means that that's going to end up to be a negative in the end. So we have negative 52 equals to 26x. That's step 3. We have all the constants on one side. We have all the numbers with the variables on the other side. Step 4, isolate the variable. Okay, well, we have 26 by the x, so that's 26 times x. That's a multiplication. Opposite of a multiplication is division. That's using our property of equality for division. So let's divide both sides by 26. And that gives us x is going to be negative 2. That's the value of x. Let's use our symmetry property. So x equals negative 2. Okay, now let's check our answers. So to check, all we're going to do, take your original and plug in negative 2. So we have negative 4 times 7 times negative 2 minus 12 equals to 100 minus by 2 times negative 2. Let's make sure that this works. Anywhere you see the x, substitute what we found. Okay, well, let's simplify both sides. 7 times negative 2 gives us negative 14, so this is negative 4 times negative 14 minus by 12 equals to 100. Negative 2 times negative 2 is positive 4. Going a little bit farther, we are going to end up with 104 on the right-hand side. Let's see if we end up with 104 on the left-hand side. Negative 14 minus by 12 gives us a negative 26. So we have negative 4 times negative 26. And negative 26 times negative 4. Negative times negative is a positive. Let's go 26 times 4. 4 times 6 is going to give us a 24. 4 times 2 is 8, plus 2 is 10. So that is indeed 104. So we have checked our work. We did simplify. We moved the variables. We moved the constants. We isolated. Then we checked our solution. That's what our steps are going to be whenever you are solving an equation. Well, just in case we didn't get it, let's do another example of this. Okay, we're going to do another example. So this one actually has fractions in it, so it's just a little bit more complicated. Remember, we have steps. Step 1 is to simplify. Let's simplify both sides. So let's first get rid of those parentheses. by using our distributive property. Distribute, distribute, distribute. Okay, well, half of negative 4x is going to be, half of 4 is 2, so negative 2x. Half of 8 is 4. Okay, negative 3/4 of an x is still going to be a negative 3/4 of x. Negative 3/4 times a plus 7 is going to be a negative, or a minus. 7 is technically 7 over 1. 7 times 3 gives us a 21. And 4 times 1 gives us 4. Okay, well, we simplified some. I also mentioned in the last problem that if we have fractions or decimals, let's go ahead and just keep that in the same step. And let's get rid of our fractions. Get rid of our fractions. Well, how do we get rid of a fraction? Well, let's get rid of the denominator. Get rid of the bottom of the fraction. The bottom of the fraction is 4. So let's get rid of the 4. Well, how do we get rid of the 4? That's a division, so we end up doing a multiplication. So we multiply this side by 4, and also multiply this side by 4. Okay, well, we multiply both sides by 4. That's our multiplication property of equality. Now let's go ahead and just do those multiplications. So this would be a negative 8x minus by 16 equals to negative 3x, because 4 times 3/4, that gets rid of the fraction. That just leaves you with a number on top. Minus by 21, that gets rid of the fraction. Leaves you with the number on top, because it's the same as the denominator. Anytime you multiply by the same number that the denominator is, it just gets rid of the fraction. You're left with whatever's on top. We have simplified. That looks a whole lot better than what we started with. We no longer have those parentheses. We no longer have the fractions. That is extremely nice. So now let's move on to step 2. Step 2 was move the variables. Get them on the same side. What I'm going to do is I'm going to move the negative 8, because 8 in general is bigger than 3, which means since it's negative, it's farther negative. So if we move the negative 8, it's going to make it so we have a positive variable. Again, it does not matter which variable you move. You can move the negative 3 or the negative 8. It gives you the same result. So moving the negative 8, remember, it's a negative, so we do the opposite, so that would be a positive, so we plus 8x plus 8x. So we end up with negative 16 equals to 5x minus 21. That is step 2. We moved the variable over. Now let's get the constant to be on the other side. So we have a minus by 21. Minus is negative. Opposite of negative is positive. So we add the 21 to both sides using our property of addition. Okay, so we end up with 5x on this side. 21 minus by 16. Okay, well, 21 minus by 16, 21 is bigger, so it's being a positive number. This will end up to be a 5. That's step 3. We move the constant to the other side. And at this point, we move on to step 4, which is isolate the variable. To isolate the variable, we are either going to multiply or we are going to divide. 5 is times by x. Opposite of times is division. So we are going to divide both sides by the number beside the variable. So we end up, again, with a 1 equaling to x. The x is on the wrong side. Let's use our reflexive property, not reflexive, symmetric property, right, from yesterday, the symmetry, to make it so that x is at the start. It's nice to have symmetry so that we can reverse the order so that we have the variable up front. So that's step 4. Step 5 is to check. So let's check our work. Just plug in your x value that you found. We have 1 over 2 times negative 4 times 1 minus 8 equals to negative 3 over 4 times 1 plus 7. Simplifying this out, this would be 1 over 2. This is order of operations. Times negative 4 minus 8 equals to negative 3 over 4 times 8. Simplifying it down a little bit more using our order of operations, we end up with negative 12 on this side and negative 3 over 4 times 8. This has 4 in common, so that would be a 1. This would be a 2. 2 times 3 is 6, and it's negative. Let's make sure that this other side also equals negative 6. 1 over 2 is half. Half of negative 12 is a negative 6, so negative 6 equals negative 6. We checked our work. That is your 5-step whenever we are solving an equation. It doesn't matter whether it's decimals, fractions, any linear equation, you can follow this step and you will get to your answer. Simplify each side. Get rid of your parentheses. Get rid of the fractions. Get rid of the decimals. After you do that, move the variables to one side. After you do that, move the constants to one side. That's always using addition or subtraction. Step 2 and 3 is always addition, subtraction, the opposites. Step 4 is always multiplication or division, depending on what the constant has, what the variable has as a constant, as a term in front of it. And step 5 is just checking your work. Okay? Moving on. Example number 6. Okay, this is example set 6 that we are looking at now. Example set 6 has us solve for a specific variable. Okay, we have the formula for area, which is A, of a circle is A equals to pi times radius squared, right? That's the area of a circle. R is the radius of the circle, and we want to solve for R. This is if we do not have numbers in it. What if we have a bunch of variables within our equation? Well, if we want to do that, we need to know what we are dealing with. So we have A equals to pi times radius squared. By the way, the steps still work with this for the most part. I say that. So A is equal to pi times radius squared. We want the R to be alone. Okay, well, there's no fractions, there's no decimals. So what we're going to do is we are going to start by getting it isolated. That squared is only with the R, it's not with the pi, so we do not want to mess with that square. That pi is times the radius squared, so let's get that pi to go away. To undo a multiplication, we have to do a division, so we divide both sides by pi. So we have area over pi equals to radius squared. R is almost alone. The only thing left with that R is a square. Well, to undo a square, we had to use the square root. So we end up square rooting both sides. So we end up with radius equals to the square root of area divided by pi. By the way, technically, this would be the positive or negative version of this. Anytime you take a square root, whenever you're solving an equation, it's a plus or minus. However, in this situation, we're looking at area. Does it make sense for our radius to have a negative distance? No, it would not make sense for our radius to have a negative distance, so we do not have to put in the plus or minus. It's just a plus version of it. But generally speaking, as we go through Algebra 2, you are going to start seeing, as we do square roots, we are going to have to remember the plus or the minus. So that is the answer to this one. If we want to solve for R, isolate it. Get it alone. Here's another one, a more challenging problem. The formula for slope, which is m, is equal, so that m is equal to y2 minus y1 over x2 minus x1, where x1 and y1 and x2 and y2 are points that we have. This is an equation that you guys have seen quite a bit in Algebra 1 and also in geometry. So what we are going to do is, let's say that we knew the slope and we knew 3 of the 4 points. We're going to solve for x1. We're going to get x1 to be alone. In order to get x1 alone, we need to be able to think about where it is. x1 is stuck. He's trapped. He's trapped in the bottom of a fraction. If we want to get him unstuck, we have to get him out of the bottom of the fraction. And if we want to undo a fraction, we have to do the opposite of whatever the fraction is. The fraction is division, so we have to do multiplication. So we're going to multiply both sides by whatever the denominator is. x2 minus x1. So we're going to multiply by x2 minus x1 on both sides. Remember, if you multiply by whatever the denominator is, the denominator goes away, so you're left with only the numerator. So we have x2 minus x1 times m equals to y2 minus y1. Okay, we have parentheses. We're trying to get x1 to be alone. It's stuck in those parentheses, so let's undo those parentheses. We're going to distribute. So this would be x2m minus by x1m equals to y2 minus y1. Our goal is still to get that x1 alone. x1 is not just by itself. It has m, and it also has an x2m as well on that side. So what we are going to do is we need to move this x2m to the other side. Treat that as if it was a constant. So what we're going to do is we are going to do the opposite. That's a positive x2m. So we're going to move that by doing a subtraction. So minus by x2m, minus by x2m. I know that there's several steps in this. If you had to go back and rewatch it, that's okay. So we have a negative x1m equals to y2 minus y1 minus by x2m. Whew. We're almost there. Almost there. x1 is almost by itself. Only thing that's stopping it from being by itself is that m and that negative. So let's go ahead and do something about that negative. Let's get rid of that negative. How do we get rid of a negative? Well, we can multiply by a negative. Okay, so in other words, what that does is it just flips all the signs. So it's be now a negative y2, a positive y1, and a positive x2m. It just flips all the signs. Whenever you are dealing with a negative, just flip the signs over. x1's almost by itself, so let's get rid of that m, so we divide by m. So we have x1 equals to negative y2 plus y1 plus x2m, and all of that divided by m. That is, if you want to find that x value, if you knew all the other parts. You can now just plug it into this nice formula here. However, in practice, in general practice, we would just graph it, and that would be a whole lot easier if you wanted to actually find what that point was. But this is more of the theoretical side of it. Okay, there is a formula so that we could find any point as long as we know some of the other information. Last part. This is going to be our last thing we do before we end. So let's go ahead and go through this. If we know that this is our equation, then what is the value of 5x plus 7? Okay, well, let's solve the equation, get x, and then just substitute it into the last part. So solving the equation, we're going to simplify. We're going to hurry about this because we're almost out of time. So in order to do this, we simplify by multiplying both sides, or by distributing. So this would be a 6x over 5 plus a 14 over 5 equals negative 2. We're still in the simplifying phase, so let's get rid of the fraction. So we multiply both sides by the 5. So we have 6x plus 14 equals to negative 10. That is by multiplication of 5 on both sides to get rid of the fractions. We already have the variables all on one side, so move the constant. So we minus by 14, so 6x equals to negative 24. Divide by 6, so x is equal to, divide by 6. So x is equal to a negative 4. That is x. I'm not going to make us check this for this one. We're going to trust that that is our x. Take this x, plug it into that. So we now have 5 times negative 4, because that is our x, plus 7. 5 times negative 4 is negative 20, plus 7 gives us a negative, that would be a negative 13. And that would be the answer to this one. So basically, we are taking little steps. We are doing one part, then we are going to add it on to the other part.